Hello everyone. Today we are going to see how to construct an adder circuit by using Tinkercad. This is the circuit diagram for adder circuit. Here we are using op-amp, that is IC741, for the construction of adder circuit. The circuit diagram requires one IC741, then 310 kilo ohms. From the second terminal, 310 kilo ohms were connected. Then one more 6.8 kilo ohm. Then two input voltage V1 and V2. Then one dual power supply. Then for taking output, one multimeter we need. Actually, this is the pin configuration of IC741. IC741 has 8 terminals. Here in the side, first leg, second leg, third leg, fourth leg. Then here the terminal started from the bottom. So fifth, sixth, seventh and eighth one. Actually, this is the configuration. The first terminal represent the offset null. Then the second one represent an inverting input. Third one is non-inverting input. Then fourth, we can give the negative power supply to the fourth leg. Then fifth one is offset null. Then sixth one, we can take the output from the sixth terminal. Then we have to give the positive power supply to the seventh terminal. Then there is no connection for eighth terminal. Actually, this is the circuit diagram I have made by using Tinkercad. That is, by using virtual lab, we can handle the classes. So, if you want to construct the circuit, we can use by Tinkercad. So, now let us see how to construct a circuit by using Tinkercad. So, for this, you have to go to Google search and type Tinkercad. When you type Tinkercad, this page will open. Here www.tinkercad.com. You have to select this and click this. Then this type of page will open. Actually, before this, already I have designed lot of circuits by using Tinkercad. So directly I have entered to this page. Before that, one page will open. In that, it will ask, there is one option, join now. You have to click join now. Then it will ask your mail ID. Otherwise, by using what type of account, Google account, Microsoft account. So by using what type of account you have to enter. That option is that. Then you have to choose the sign in option. Then it will ask your mail ID. Then you can enter the Tinkercad through your mail ID. So you have to sign in Tinkercad by using your own mail ID. Then this page will open. Here lot of options are there. We can construct 3D designs, we can construct circuits, we can construct code blocks, then we can construct lessons. Here we are going to construct the circuit. Therefore, I am going to choose this option, circuit. Then this page will open. Actually, here lot of circuits are there already I have designed. Therefore, otherwise for the beginners, this page is empty. So simply this option is there. Create new circuit option is there. So you have to click create new circuit. Okay. Then the screen will open for you. Here the components for our electronics lab. What are the components required for our electronics lab are available in this side. So we can search anything and we can choose anything for our circuit. So for this adder circuit, first we need one breadboard. So I'm going to type breadboard. Then here breadboard is here. Kinds of breadboards are available. Breadboard mini, breadboard small. So like this, all the types are available. Here I'm going to choose breadboard small. Then you have to click it. Then you can drag it outside. Okay. Next, by using this option, we can rotate the keyboard for our convenience. Okay. So now breadboard is ready for our circuit. Next, we need IC 741. Therefore, 741. Okay. Here, op-amp is available here. Then click. Then drag it outside. Then I'm going to rotate this for my convenience. Then I'm going to drag it and fix it like this. Okay. So now our op-amp also ready. When we look at the circuit diagram, from the second terminal of IC741, 310 kilo ohms are connected. Therefore, I need 310 kilo ohm resistance. Next, when you drag out the resistance, this box will appear. Here you can change the resistance value. Already here 1 kilo ohm is given. Now I'm going to change this one as 10 kilo ohm. Then I'm going to fix this one to the second leg. Okay. Then next, second resistance. Here also I'm changing the value 10 kilo ohm. Then here the legs of the resistance cannot be extended. Therefore, you can place it anywhere of the breadboard. Then from this, you can give the connection to the second leg by using the wire. Therefore, you are going to place this one to somewhere else. Okay. Then similarly, the third resistance. And also here also I am changing the value 10 kilo ohm. Then drag it. Then I'm going to place it here. Okay. Now I am going to make the connection between this second and third resistance with the second terminal of op-amp by using wire. So from this and to the second leg. Okay. Then from this to second leg. Okay. So now our connection is over. So from the second leg, 3 resistance are there. This is the first resistance. Then this is the second resistance connected with the second terminal. Then this is the third resistance connected with the second terminal of op-amp. Okay. Next, from one of the second resistance, from one of the resistance, connection is there between the second resistance and the sixth leg of op-amp. Okay. So this connection is over. Next, we need V1 and V2 for input and also one dual power supply for positive power supply and negative power supply. Then we need one 6.8 kilo ohm. Then also we need one multimeter for taking output. So now we are going to choose that components. So first I am going to choose power supply. This is for V1. Here I am going to set the voltage 12 volts. Okay. Then next power supply. When you click, this box will open. Then you can change the voltage value 12 voltage. Okay. So for our convenience, for our understanding, now I am going to naming the two power supply V1 and V2. Therefore, here one option is there. You can click it, then you can drag it, then again you can click it, then it will appear. Then you can write this is V1. Okay. Next, again for the second one, you click this, then drag this. This is V2. Okay. Next, I need one multimeter. Okay. Here, mode is in voltage itself. Therefore, we not we don't need to change the mode. Otherwise, you can change the mode. If you want to measure the current, you can change the mode amperage. Then if you want to find out the voltage, you can keep the mode voltage. Otherwise, if you want to find out the resistance value, then you can keep the mode as resistance. So now we are going to measure the voltage. Therefore, we are going to keep as it is because already the multimeter is in voltage mode. Next, we are going to consider dual power supply. Therefore, for this, I am in need of two power supply. Okay, going to keep one in this side, changing the value 12. Then next one for our convenience in this side, and also here also I am changing the value 12. Then we are going to give the name. So actually this power supply will act as negative power supply. Therefore, here I am writing negative VCC. Okay, then this will act as a positive VCC. Therefore, positive. Okay, now I think one more 6.8 kilo ohm we require. Here I am changing the value from 1 to 6.8 kilo ohm. Then this 6.8 kilo ohm should be connected to the third terminal of op-amp. Okay. Next, we are going to give the connection for V1 and V2, that is input. Actually, already we have connected 310 kilo ohm. So one of them, the other end of one of them connected with the sixth leg of op amp. Then next, from the another resistance and from the third, from the first resistance, the other end connected to should be connected to the positive of V1. Similarly, from this is the third resistance, 10 kilo ohm. So here also, from the other end of the third 10 kilo ohm to the positive of V2. Just you can hold your mouse and you can drag it. Then the wire automatically can change their direction. Okay. So these two are positive connection. So I would like to change the wire color. So just click the wire. Then this box will appear here. Then you can change the green to red color. Okay. Then this is also positive connection. So here also I am going to change this one as red color. Okay. So now both the negative ends of V1 and V2 connected together, then it will go to the ground. So now I am going to connect both the negative ends. Actually, this is negative connection, sorry. Actually, this is negative connection. Therefore, here changing the color as black. Okay. Next, from the sixth leg, we can take the output. So the positive terminal of multimeter should be connected to the sixth leg of op amp. So here I am clicking, then to the positive end. Okay, actually this is output. Therefore, here I would like to change the color. We can choose purple color for output. Okay. Next, here also from V1 and V2 the positive connection. That means this is V1. So the input color may be different. Therefore, I would like to change the input V1 as yellow color. Okay. Then the input V2 as any other color, pink color. Okay. So the yellow color represent V1, that is one of the input. Then V2, the purple color represent V2, that is another input. Then this color, this pink color is V2, then this purple color is denoted by purple color output. Okay. Then here this power supply will act as positive VCC, then this power supply act as a negative power supply. So let us see how to make this connection. So for this, already in the breadboard, in the topmost, you can see here plus symbol and minus symbol. Here also plus connection and minus connection. So Now I am going to make the positive power supply. Therefore, from the positive to positive of breadboard. Okay, so this is positive connection. So the color is red. Then from the negative to negative of breadboard. This is negative connection. Therefore, the wire color is black. Okay. Here it will act as a negative power supply. So here one thing you have to remember, from the positive to the negative of breadboard. From the positive to the negative of breadboard. So this will act as negative. Therefore, it is black color. Then from the negative to positive of breadboard. So this color is red. Okay. Now the other end of the 6.8 kilo ohm resistance should be connected to the ground. Therefore, from this, okay. So this is one negative connection. So here I am preparing to change the color as black. Okay. Now I think, okay. Then from the negative end of the multimeter should be connected to the ground. This is also negative connection. Therefore, here I would like to change the color as black. Okay. Next, common ground connection. Therefore, from this to this negative. So now I have completed the common ground connection. So this is black color. Okay. One thing we have to remember, from the 7th terminal, positive power supply should be connected. Then from the 4th, negative power supply should be connected. Therefore, from the 7th leg, seventh to this positive. So red color. Okay. Then from the 4th leg to negative power supply, actually this side, this will act as the negative power supply, because from the negative terminal we have connected to the positive of breadboard. So this will act as the negative power supply. So this connection is black color. Okay. So everything is over. Now we are going to check whether our circuit is correct or not. For this, you can give the input values and you can start simulation here. When you press this simulation, you will get an output. So now I'm going to set the input voltage from V1 6 volt. Then for V2 5 volts. Actually, the output is minus of V1 plus V2. Okay, so 6 plus 5 means you will get minus 11 voltage. So we have to check. Wait. Oh, sorry. So here V1 plus V2, both the negative ends of V1 and V2 connected together and also to the common ground. Okay. So now for V1, I'm giving 6 voltage. For V2, I'm giving 5 voltage. Then start simulation. So minus 11 volt we got. So we can next for one more input. Then for V1, here I'm going to change the value 3 volts. Then for V2, I'm going to give, then the value is minus 9 volt. Therefore, our circuit is perfectly correct. Okay, thank you for watching this.